So thanks very much indeed. I feel very privileged to be on this main stage, and I hope there's a good audience still here, because of course it's nearly home time, and I understand that 10 o'clock tonight the UK drops out of Europe, so anyone who wanted to get a flight and arrive back in England should probably leave now, just to be sure. Anyway, so I work for Digital Catapult. We're a company based in the UK. Our headquarters is in London, and our mission is to accelerate the early adoption of technologies in the UK. And of course, by that we mean a number of technologies. We have immersive, very topical, artificial intelligence, and the most important area, in my view, is what we call future networks. And that's everything from 5G at one end to the really most important LPWAN, LoRaWAN, that sort of thing for IoT. So that's what we do. That's the sales pitch over. So we got this fantastic project to work on, and so the title is Going Faster with LoRaWAN. I was going to call it, going faster than 5G, but of course, since someone at the Catapult works in that area, he may be irritated with me. Anyway, we start with a bit of geography. So there's a place called the Kalahari Desert in South Africa. It's 900,000 square kilometers of desert. Occupies almost all of Botswana, eastern third of Namibia, and of course the northern Cape of South Africa. In the southwest, it merges with the Namib, which is the coastal desert. Daily temperatures out there reach about 45 degrees, and if you put something out there in the sunshine, it'll be much hotter than that. The dry season's about 8 months in total. It rains for about 1 month, which is why you get these plains in these very flat areas. You get maybe half a meter of rain in 1 month, then it dries up again. And of course, it's windy and dusty because it's the desert, right? It's the home of many migratory birds. Wild animals wander across the plains. Zebra, impala, ostrich you'll see out there. You see occasionally predators such as lions and tigers. Riverbeds are grazing spots for animals, so they all come to the grazing spots, and you can have a good time looking at the nature there. And of course, there's always meerkats to be seen. It's quite different to the UK, probably quite different to the Netherlands, which is basically a green and pleasant land, right? So in the desert, there's a place called the Hakskeen Pan. It's a dry a dry lake, so it rains there. The water stays there for a few weeks, and then it drains away. It's pretty flat. And a typical day in the Hakskeen Pan, if you drive along the dusty roads, would look like this. So it's fairly average place, not particularly interesting. But something rather special happened on November 2019, which is this particular vehicle, which is called Bloodhound LSR, which stands for Land Speed Record to be precise. That car was out there, and I was privileged enough to go there too. And the company I work for, Digital Catapult, were supplying them with something rather interesting. So before we go into the car, I want to tell you about this company who built this car. It's actually, I guess, a company you could say not so different from the TTN. There's like 25 engineers working together for a few years. They had this idea. They wanted to build a car that went pretty fast. And they're based in Gloucester. They're based on a small industrial park. And they basically designed and built the car by hand by themselves. I mean, there are parts they bought, some spare parts, but essentially everything that you see, they made it, right? And the aim is to break the land speed record, okay? And they may be able to go 1,000 miles per hour, but they've not done that yet, and we'll see. So, some stats about the car. It weighs 6.4 tons. The current land speed record is 760 miles per hour, which is over 1,000 in European. And they're aiming to go that fast next year, but they had built the car, and the fastest they had been in the UK was 200, and they wanted to check whether the computer model simulations matched what they thought it would do. So they wanted to take the car out to the desert to do some high-speed testing. The car is capable of going 1,000 miles an hour, I should say. Some nice statistics. So the wheels, which are solid aluminium, the force at the edge of the wheel is 50,000 G, and they rotate at 10,000 RPM. So it's not the engine rotates at 10,000 RPM, the wheels rotate at 10,000 RPM, which is quite spectacular. In terms of its engine, it's driven by a prototype Eurojet fighter engine built by Rolls-Royce. That's not enough. It needs to have more power to go even faster. So that's also augmented with what's called a a Namo monopropellant rocket engine, which actually is only about this big and generates almost as much power as the jet engine. So the propulsion system generates a total of 212 kilonewtons of thrust, and the aim is to beat the record, beat the land speed record at the moment, and maybe 1,000 miles an hour. This is a guy called Andy. He's the driver, or maybe we could say the pilot. So he's ex-RAF, he is a pilot. He is the current holder of the land speed record that was set about 20 years ago, and he wants to go a bit faster now. He's also incredibly tall. So why the Kalahari? Well, it's really, really flat. I mean, this I think it should be on the next slide. Here we go. So the Hackskin pan, it's basically 16 kilometers long and about 2 or 3 kilometers wide, and it drops only 30 centimeters over that entire distance, and the maximum dip is about half a centimeter. So it's absolutely flat. It's perfect for this sort of thing. It's also good because lots of people, when they think about land speed records, they think of the salt flats in the US, but the ground's quite hard there, and it really hammers the car, hammers the suspension. So Hackskin is sort of soft, dry mud, so it's much better from a grip perspective and from a sort of suspension perspective. It's very flat, very wide. It's kind of in the middle of nowhere, so if things go wrong, there's plenty of time to recover from that sort of thing. And over 21 million square meters of desert were cleared of any stones and debris by hand by these guys over the last sort of 5 or 6 years, whilst the team's been working with the South African government to get permission to do this. It's quite an amazing feat. But it can be windy. It's the desert, and winds can get up to sort of 40 miles an hour, and the car absolutely doesn't like crosswinds. So if the crosswind is more than about 15 kilometers per hour, they would choose not to run the car. I should point out that the car is currently funded by a guy, an individual, another engineer, who used to make turbochargers, and he's basically put £15 million into the project, and essentially every day that the car is out there is about £200,000. So it's an expensive venture. So they want to make the most of it, and if maybe they get 4 or 5 runs a day when they're testing it, if you make a run and it's wasted, it's lost, it's a waste of £50,000. So best get it right. So if it's windy, they will wait a bit. So the challenge, we wanted to measure the wind speed, direction, temperature, humidity, and pressure at 1 mile increments, or 1.4 kilometer increments along the track. There was the option for a solar-powered gateway, because there's not a great deal of power out there. And sensors were going to be potentially 10 kilometers from the base camp. So there'd be a base station at their base camp as well. And they wanted to have data in near real time, which was pretty good with LoRa. And of course, they wanted to collect the data for post-analysis, because they'll be comparing the telemetry off the car with the models, with what actually happened on the track. So the Catapult had built this thing, which we had called WASP, Wide Area Sensor Platform, and our existing customers that we had were the Royal Air Force, Royal Navy, and a company called NSG, who make glass, window glass. Ironically, the one thing it didn't measure was wind speed, which was kind of the most important thing for the Bloodhound team. So we had to fix that. So we teamed up with AWS. They're a company that, of course, a lot of the TTN stuff is based upon, but we work with them a lot as well. So most of our platforms we tend to build on AWS, and AWS gave us some money to buy some sensors with, because we were aiming to not charge for this. It was a gift to the Bloodhound team to help them get the record. So we basically needed to choose a sensor and a gateway to be able to deal with this. So we needed something that was able to be quite robust, survive desert environment, good battery life. Although we don't need 6 months in this case, it's nice to have that provision just in case they have to stay out there for longer. We want readings every 3 minutes or so. It's got to have no moving parts, because of course there's lots of dust out there, moisture resistant, and of course being able to deal with an ambient temperature of 40, 50 degrees when you're in the shade, and maybe 70 degrees if it's in the sun. So we went out and had a good look, and we found this amazing sensor from a company called Decent Lab. They have a stand here as well, and they were fantastic, because we said we needed these sensors, about £15,000 worth of them, and we told the guy, we haven't actually got the money yet from Amazon, so will you trust us? Can we kind of order them, and I promise we'll pay? And he was fantastic, and they arrived on the day they were supposed to arrive. All the libraries were pre-provided, all the keys were there in a nice Excel spreadsheet, and they just worked. They turned up on the day promised, perfect, and they came up on a network absolutely perfectly. They measure wind direction, speed, they can do gust, and they do temperature, and of course battery life. And then we also chose to use these Sagem-Com zirconia sensors to measure the pressure. Why do we need to know the pressure? Well, it's got a jet engine, right? And the jet engine runs better when the air is dense. And in the daytime, it's 40 degrees. In the morning, when we did most of the test runs, it was 4 o'clock in the morning. It was a bit cooler. And the pressure helps them to optimize the jet engine performance. I've got a great story about the jet engine, which I will tell you some other time. There's not enough time for that now. But let's just say that it was driven by some handmade electronics based around an Arduino, I think, which is quite spectacular. Okay, the zirconia code is quite neat. Zirconia is one of the very few devices that you can actually program your own code onto it. So we chose to use it for other projects. So the devices cache the data if they're not able to join to the network, and then as soon as they connect up, they offload, which again wasn't really needed for this project, but it's a good device to consider. Were it not for the fact you can't buy them anymore, but it was a good device. In terms of gateways, we chose to use Kerlink. We have a lot of experience with them. They're pretty robust, and we had a bunch of them in the store, so we decided to use the Kerlink gateways, which we set up. We gave them 4 gateways, but they actually only were running off 2, which was more than enough to cover the 16 kilometers with a bit of redundancy, and it was fine. And we were using 3G backhaul, so you put a SIM card in it for backhaul. We also had the provision for it to be solar powered. As it turns out, we didn't need to use this, but we built a solar panel array and a battery pack and this sort of thing, so that if there wasn't power available where they wanted to put the base station, the gateway, we could run it off this. It has a 15-day battery life if there's no sun. That wasn't really a problem in the Kalahari, so it would last forever. Of course, we used the TTN network. TTI spun up a private instance for us. Took them about 35 minutes, I guess, from when we put the telephone call in. And all of the usual things that we get with the TTN, TTI. We use the dashboard for provisioning sensors, gateways, and all that sort of thing. And then our platform talks to the TTI backend. Our solution, it all runs on AWS, based on Node.js. There's a guy called Matt, who's sat in the audience in the back there. He basically built it all. And it's got a Postgres database and a node-based backend. We're hosted on TTN network server. Sorry, integrated on a hosted TTN network server, to be precise. This is what the dashboard looks like. It's got a rows of data for each sensor. You can have the slides afterwards if you would like them. And it measures various things, and you can set alarms and plot graphs and pull out the data and all the things that you'd expect from a really awesome dashboard. So that was built. I then took all of the sensors which arrived to a field at the side of my house. My son, who's 11 years old, called Adrian, he helped me set these up. They're all set up on broom handles to simulate what they're going to be like, and we put them out in the field, tested them all, they all came up instantly. There's a couple of gateways in the back that you can see there, and they all perfectly worked. So that was our testing. On the topic of testing, and this is the only bit of sales pitch I'll do, we also are starting to do battery level testing and performance testing of any devices that you might like to have. If you happen to be in London on the 11th and 12th of March, come to our stand. We'll happily, free of charge, test your sensor device. And then if you'd like a more robust, a more thorough set of tests, let us know and we'll come to some sort of deal. Okay, so delivery of the gateway. So I basically hand delivered the gateway to this place in Gloucester. This is the chief engineer who's responsible for all of the telematics and sensor systems on the car. So we put them in some nice flight cases to make it look kind of professional. Delivered it, gave him half a day's of training how to use it, how to set it up. And the picture on the left-hand side at the bottom is their steering wheel of the car, which is 3D printed out of titanium. And I said, why did you do that? And they said, because we could, because it was fun. So yeah, that was that. I then had to prepare for the trip. Like all great British travelers, I was fully prepared. So I had a camera, some goggles for the dust, some boots, ear defenders, because we're going to be standing next to a rocket engine or jet engine, and some Nurofen, Imodium, which I never used. It was fine, and a bit of cash. So it was all good. This was our journey. So we flew from London to Johannesburg, then Johannesburg to Uppington, then from Uppington to another place, which the name escapes me, which is Malopo Lodge. And then Malopo Lodge is 60 minutes from the test track. The journey takes about 2 days from London to there. So it's not something you do for a day trip. This is the hack ski and pan. This is where we arrived to do the testing. Okay, so this is the car on the track. This was when they first fired up the engine. Lots of the media said, why is there smoke coming out of the back? That's not a good sign, is it? Actually, it's completely fine, because when you put a jet engine into storage for a few months, you spray it with oil to keep it rust-free, and that was the engine oil burning off. So the car's kind of ready. Then this was us deploying the sensors. They're all out there in the desert. We've got, this is the control center in these cabinets. There's a curling gateway on the outside of that was put there. All of the route planning was done with basically bits of tape on a desk and milk bottle tops or drink bottle tops to show where the marshals and the car go. So the route planning was all done. Marshals were ready. So they had marshals along the side of the track in case anything goes wrong. It's one of the marshals. We had AWS team out there supporting us should we need any additional instances spun up, that sort of thing. So they were out there. And of course, we wanted to check the wind speed, and that was the whole point. So the video you're going to hear in a few minutes, which I hope the guys will turn the volume up for, because it's kind of interesting. Listen for the references to, it's a discussion between the driver and the control tower, control center, talking about wind speed and pressure and all that sort of thing. So if we're all ready, are we ready? Let's go.
Control, good morning, this is Ange.
And Control, good morning. All stations, please keep your speed low as you transit out due to dust. LoRaWAN Control, good morning. Temperature is +17 and pressure 923 millibars.
Okay, welcome back to the Hack Skin Pan. Really good day today. We had an early start to make sure that we had good cool conditions and calm wind, and that worked perfectly for the car. Plenty of engine thrust in the cold air and no wind to push the car off track, so it ran dead straight all the way. Target today was 550 miles an hour, 880 kilometers an hour. We just exceeded that, got to 562, which is 904 kilometers an hour, fastest speed yet, and the best run we've had today.
So that's how you get fast. So the highest speed they achieved was 628, which was over their target. If they go back next year, and I say if in a minute, why? They're aiming to go beat the land speed record, maybe get up to 1,000. They need about £10 million to fund the project. So if anyone would like to invest £10 million, they can basically buy the rights to be there as well and brand it and do whatever you like. So that's a call out for them. So go to the Bloodhound website if you have some spare cash for that. That's it.
Thank you very much, Peter Karney.